you watched my previous video on complex numbers, you saw that arithmetic with complex numbers is really not that different than arithmetic with just real numbers. Okay, but when it comes to division, it's still not difficult, but we have an extra step to consider. And so I want to look at this example here. I'm dividing 1 by 1 plus 2i. Okay, now this should end up as a complex number, so it's got to be a plus bi. But how do I find that? Okay, well there's a clever trick, and I'm just going to jump to it and show you. I'm going to multiply by a special number. Okay, I'm actually going to multiply by 1, but in a special way. I'm going to multiply 1 minus 2i in the denominator and in the numerator. Okay, now why would I do that? Alright, so let's think. In the numerator, I have 1 times 1 minus 2i, which is just 1 minus 2i, nothing special there. But in the denominator now, I have 1 plus 2i times 1 minus 2i. Okay, now if you're paying attention, yes, the numerator and the denominator can simplify, but then you'd be back to where you started, so don't do that. Instead, let's try to simplify the denominator. Okay, so I'm going to do that by foiling. And foiling, I have first times first, which is 1. I have my outside terms, which is 1 times negative 2i, so I get a negative 2i. The inside terms, 2i times 1 becomes plus 2i. And then my last terms become negative 2i times 2i. So in other words, a negative 2i squared. Alright, now this is going somewhere. My numerator, just leave alone. But watch what happens in my denominator here. I have a negative 2i and a plus 2i. Those cancel out. And I have a negative 4i squared. And what's I squared? Oh yeah, that's right. I squared is negative 1. This becomes positive 4. So when I multiply this together, I ended up back as a real number. So here I have 1 plus 4. In fact, my denominator is now a real number, period. It's 5. So I can write this as a complex number as 1/5 minus 2/5 I. And there it is. 1 divided by 1 plus 2i is at 1/5 minus 2/5 I. Okay, now how did I figure this out? The trick is dealing with something called conjugates. And the conjugates are the opposites in terms of their sign. So a plus bi and a minus bi are conjugates of each other. And the interesting thing is when you multiply conjugates, so a plus bi times a minus bi, when you FOIL this out, you'll always end up with a squared plus b squared. The middle complex terms in the foiling will subtract out. Your last term will be negative b squared I squared. I squared is negative 1. So we end up again with a squared plus b squared. So you may be saying, wait a minute, that's a special binomial, right? That doesn't factor. A squared plus b squared doesn't factor. Well, it doesn't factor in the real numbers, but in the complex numbers, yeah, it does factor. And knowing that helps us with division. So let me show you some other examples. We'll just practice the same thing. Hopefully it makes sense. Okay, so here we just have more examples of this. Part A, we have 3 over 11 minus I. Okay, so I already know the trick, right? I'm going to multiply by the conjugate. 11 plus I over 11 plus I. In the numerator, I'm distributing a 3. I get 33 plus 3i. What about in the denominator? Okay, I'm going to FOIL this, but I know the trick when I multiply conjugates, right? It's going to be 11 squared plus 1 squared. Okay, so that's 33 plus 3i over 121 plus 1, 122. So that's going to be 33 over 122 plus 3 over 122i. And there's my answer. And do you have to write it that way? Some textbooks will accept this as a correct answer. But technically the definition of complex numbers say a plus bi. So I like to do that. Alright, let's do the same thing with part B. I have 2 plus I over 5 minus 2i. Now even though I have a complex number in the numerator here, I still multiply by the conjugate in the denominator. I'm going to write this in yellow so it doesn't get mixed up with the previous work. Alright, and so in the numerator now I have to do some foiling as well. Okay, so that's going to be the first terms, I get 10. On the outside I get 4i. On the inside I have a 5i. And then lastly I have a 2i squared. Okay, so we'll simplify that in a little bit. In the denominator, since I'm multiplying by conjugates, I already know how this is going to go, right? It's going to be 5 squared plus 2 squared. That easy. All right, so in the numerator now, let's think. The only thing I have to really consider is that 2i squared, remember, is the same as 2 times negative 1. That's a negative 2. Okay, so when I add 8 and negative 2, or I'm sorry, 10 and negative 2, I get 8. And then I have a 9i over 29. So I could write this as 8 29ths plus 9 29ths I. Just like that. There's my answer. All right, let's look at one more, part C. So in part C, again, I'm going to multiply by my conjugate, which is 1 minus I over 1 minus I. So in the numerator, technically I have 1 minus I squared. Let's FOIL that out. So you have first is I, or 1. Outside is negative I. Inside is negative I. And then last, you have plus I squared. In the denominator, I'm multiplying by conjugate, so I get 1 squared plus 1 squared. All right, so I squared is the same as what? Negative 1. So I have a 1 minus 1. Those go away. I end up with negative 2i. And in the denominator, I have 2. Which means this simplifies then as just negative I. That was surprising, right? 1 minus I divided by 1 plus I is the same as negative I. Okay, division in complex numbers looks kind of funny, but if you just multiply by the conjugates, you're going to be safe. If you have any questions on this, I'd be glad to help, and thanks for watching.